Well, greetings, students. We're going to work on our next project, which is the support plate B. You may want to open this up in your computers. The material is 4140 pre-hard, and we're going to do this project in two steps. The first step, of course, is going to be to the right here. We're going to do the bottom half first. And the reason for that is because we have a 3/8 raised area here that we can grip on with our vise. This whole area that would be 3/8 thick. We can grab onto this with our vise, put it under parallels, and then we can begin by doing this particular part first. And we will proceed with machining out the slots, the chamfers. We will do the pocket here, and also the 1, 2, 3, 4 screws. Drill and tap them. So let's begin with this right now. The first thing, a couple of things I did in advance is I created a chain, not a chain, but geometry all the way around this part to represent our particular material. So this is the material here that I did in advance. Right? And so I'll begin by creating a chain around that so that we can use that for our simulation purposes and also for face milling. Now we're going to face mill this in two steps. We're going to face mill the top and take off 60 thousandths. We have a 1/8 to take off the material. You see that the part here is 1 3/8 thick. So our material is 1.5 inches, so I'm going to take 16 thousandths off each side so that we can bring this to height once we do this final side. So we'll take a 1/16 off this side, machine all this, flip it over and do this side, take a 1/16 off of this side to bring it into 1 3/8, and then we will machine this area last. All right, so here we go. We're going to go ahead and we're going to create our chain to represent our material and also for our face milling operation. You will also notice that I did in advance is I put our Cartesian coordinate for a spree at the lower right hand corner. That's because that when it's over here, the lower left hand corner is the reference point for the drawing, and when we flip this to the side view and then finally to the back view, that becomes on this side. So our reference point then has to shift to this side when we do this back part. All right, so we've done that, and we have our layers are already created too. As you'll see here that the geometry disappears and the dimensions disappear, and the machining, of course, is yet to be done. So we'll want to go to the machining portion right now and hit current, and to make sure that everything we do at this point is going to be machining. So I'm going to put this in the machining portion of the layers. And now our first chain will be in the machining layer. All right, the next thing we want to do is we want to create chains around these slots. And I'm going to go to the, I'm going to keep my end mill to the right of the profile all the time in every one of these slots and the chamfers. So we'll start with this one, and we will create a chain using auto chain, starting here to there, to there, to there, and then finishing it up right there. We'll hit close up here and close that. We'll come down here and do the same thing with this one. Again, we're going to stay to the right of the profile. And then our next one. Again, staying to the right of the profile. And close it. And then the final one, again to the right of the profile. And we'll close that. I guess it didn't take that one. Try that again. It's a little slow here. All right, the next thing I want to do is to do the same thing with these corners. I'm going to be creating a chain on the chamfer itself to represent the tool path. So we'll start with this one up here. We use single chain and start here, and then to there, and then to there, and close it. And then we'll do our next one. Again, we're going to be to the right of the profile, just like we were with the slots. And then our final one. All right, so we have those things taken care of, and now we want to create a chain for the pocket itself. So I'll use auto chain. I'll come down here to where the intersection would be, and I'm going to go to the right and then come back and click on the end point, and that'll close that. So now we have everything done except for the drilled and tapped holes. So we'll go in here to manual chain. We'll start here, advance to here, to there, and to there, and we'll close it. So that will represent the chain for both center drilling, and tapping. All right, so we'll save this. And the next thing we want to do is to create some tools to do the operations. So you'll notice up here at my upper right hand corner that I've created these tools. We have our center drill, we have a 159 drill, we have a 250 finish end mill, a half-inch finish end mill, a 1032 tap, and a face mill. I labeled the face mill as tool number 1, so if I open that up, you'll see that I have 2-inch face mill here. I have tool number 1, and under tools here, remember all these have to be home, and we have to have this thing mounted into our magazine. So it should say head station 1, and then the direction is Z plus. That will be for all of them. 2.75 diameter is going to be our holder. Distance protruding from the inside is going to be 2, and the tool length finally 1.250. It's a cylindrical face mill, 1.875 in diameter. It's a little bit undersized in the shank itself. Again, it remembers the 1.250 protrusion. The cutting length here is 3/8. Our final for this is 2-inch diameter, 0.625 sticking out from the bottom on a 10-degree angle, 375 from the bottom up, 4 inserts, 1.875, it remembers that, and of course it remembers the 1.250. And then here at the bottom, we have a rectangular insert, and 032 is going to be our tool nose radius. 375 is the width, and 0.5 is the length on this insert. And we'll say OK. Tool number 2 I have is the center drill, although we won't be using that right away, and I'll explain that in a moment. But we'll be using our drilling, center drill, drill and tap. We'll be doing that at the final end of the machining operations here, because we're putting a pocket in here, and that's the reason. All right, so number 3 center drill, tool number 2, coolant on, everything's the same there. Again, these are all the same. Our holder, you can take a look at this and see what they are, and our shank, and again the final part, which is important, the pilot itself, the angle of the pilot, the distance of it, and so on, as you see here. And we'll close that one out. The next one, tool number 3, is the 159 centered drill itself. Tool number 3, everything's the same here. Again, these are all the same. The holder is pretty much the same. It's a 159 diameter, sticks out about 2.5 inches, and the cutting length would also be 2.5 inches. Lastly, 159, 118 degrees included. Tip there is calculated for you at 0.0477, and so on. And we'll close that one out. Number 4, it's going to be our tap, 1032 tap. It's actually 190-32. 10 stands for 190 thousandths diameter, and 32 threads per inch, of course. Tool number 4, everything looks the same here. Good here. Tool holder. The tap is sticking inside and coming out at 1.750, and the actual the length is outside the holder is 1 inch. And we have cylindrical, of course. 190, as I mentioned, is the shank diameter. The tool length is still 1 inch, it remembers that, and the actual length of the cutting is 625. Again, it remembers the 190. The 032 is the pitch, so if you put 32 in here, it'll put 031 too for that, and the tap angle is 0, cutting length of 62.5, 2 flute, 190, and of course the 1 inch protrusion. Okay for that one. Tool number 5 is a 1/2 inch finish end mill. So everything's the same here. Everything's the same there. We have pretty much the same here. And the tool length is sticking, the cutting length is 1.5 inches, which is important so that we make sure we have enough flute length. We need at least a flute length on this of 1 inch to be able to go around this, because we notice that right here this is 1 inch, so we're going to be cutting our chamfers in that, and we're going to be cutting our slots also are all the way through this 1 inch area here, as you see. If you just run your eye across, you can see these slots are portrayed on this side view. So we want to make sure that we have a flute length that's long enough to cut that. So our flute length here is 1.5, so that's more than enough to do that. And okay on that. And then the tool number 6, our last one, is a 1/4 inch end mill. And that we're going to be using to pick out these corners, because you'll notice that the corners are 187.5. If we use the 1/2 inch end mill in here, a 1/2 inch end mill creates a 1/4 inch radius, so that would actually be too big for this corner. So we're going to pick these corners out and finish this wall and the floor with the 1/4 inch end mill so that we can clean all that out. We'll rough it out with the 1/2 inch, and we'll come back in with the 1/4 inch and finish the pocket out. Also, the pocket, these pockets right here, or open pockets, will be we'll be using the 1/4" end mill for this too, because you'll notice that they are only 3/8 wide. Okay, so this is the same here. We have our distances. We need to stick out 1.5" here, 1.5" sticking out, and our flute length is 1.25". That'll be enough to do it, to do the slots with it. And lastly, 1/4" 1.250 for flute, 250 diameter, and 1.5". Okay. So we've created all of our tools, and we are now ready to begin our machining operation. So we'll start out with the face milling operation. So we're going to want to pick up our first chain that we created, that goes all the way around the periphery of the piece. Right? You can also pick that up here as well. You'll notice you'll have chains here. Chain 1 is that one. And we're going to say machining, style mill traditional, and facing. Up at the top, we're going to put facing up here for our operation name. We're going to pick up our face mill. We're going to put in here 1,000 RPMs, 15 inches a minute for XY feed, and 10 inches for Z feed. Our strategy is going to be zigzag, 1 pass, no. Optimal cutting angle, yes, and segments. We want to make sure that we have segments going across and back, across and back. We could use arcs, but then we're going to lose some of the arc that is created might not get the corners, so we'll use segments this time. We want to step over 1 inch, which is 50% of the 2-inch diameter face mill. The overhang is going to be 1/2 inch. It's 25% and 100% feed rate both ways, no islands, and there will be 0 for our allowance on the floors and the walls. So we don't have really we do have a floor, but we're not going to leave anything on there. We're going to basically make the top surface of this Z0, and that's important because if we don't make this top surface Z0 and we tell it to come down another 1/16 of an inch here for the if we tell it to leave 62 thousandths on the floor, it will not be able to see the geometry here to be able to machine it for all the other operations. So we want to make sure that we consider this to be Z0 for step number 1. So I'm going to leave these at 0. The total depth is 0. Incremental depth is 0. Stock allowance is 0. And floors is also 0. Full clearance, 1 inch. These are pretty much common. Our lead in, lead out, down and over, over and then up. And we're going to say OK on that. Now we want to create the simulation parameter. I want to go to our simulation parameters, and we want to create this chain, make this chain our simulation solid. So we will go into, I'll go in here and take this out for the moment, and then start from scratch. And I'm going to go in here. I'm going to go to solids. I'm going to click on extrusion. I'm going to put in here 0.625. So that's going to simulate 62 thousandths extra material off the top of the piece to bring it to Z0. And then what will be left is 437.5. We will need to take another 62 thousandths off the other side when we do the second operation, and that will bring it into 1 3/8. And we're going to say here, grab the chain and say yes, and then hit add and hit OK. So at this point we should be able to simulate this, and we should see what we have. There we go, and you can see I can see my geometry now, And now I'm ready to do the other operations on this particular side. Okay, the next operation is going to be doing the chamfers. We're going to be using in fact, I think what we'll do, and rather than doing that, yeah, we'll do the chamfers first. So we'll start with this one. And we'll say machining, solid mill traditional, and we'll say contouring. And we'll come in here with our 1/2-inch end mill and put in our speeds and feeds. Our strategy, we'll put in here 1 rough pass, a finished pass, yes. Cutting strategy will be conventional. Notice we're always going to be staying to the right, so we're going to go ahead and cut these out conventionally. So we're going to start back here and move forward on each one of these. So we're going to say finish pass conventional with spiral move, no. We're going to leave 10 thousandths on the walls, nothing on the floors. And the total depth will be 1" 20. The reason why I want to come down 1" 20 is because I want to make sure I get just a little bit past this 1 inch here with my machining operation on this side to make sure that when we flip it over that we have no burrs in here on our slots and on our chamfers. All right, so we're going to go at 270 increments to make sure that we sort of split this up a little. And then we're going to go to the right, as we said, of the profile. Tool offset radius, yes. Cutter comp, right. And then we want to make sure that we're using the correct tool. So when we look at our tools, under here, we see that tool number 6 is the 250 finish end mill, so that would not be correct. We want to be using the 1/2-inch end mill for this. So we want to make sure that we make this 5. And finish. Our finished speeds and feeds will be the same. Tricycle move, no. Trimming, collapse, and you can see what I have here. Links, down and over, feed over, wrap it up. And we're going to be using tangent. Now, tangent is very important to use when you're doing outside profiles like this. And we want to start our tool, let's say right here, and then advance forward. We want to lead in tangentially. So we'll see what that looks like. And I'm going to make sure that I'm away from this part far enough, because I'm using a 1/2-inch end mill. I've got to stay away at least 0.25. So I'm going to go a little bit more than that and make it 270 so that I don't crash into this when I come down. And I'm going to do that for both of these, and I'm going to say OK. And now we will see what that looks like. So if I go into my machining here now, I can go in here and I can single step this, and you can see how this is going to come across. And then come up and take another bite, come up, take another bite, come up and take another bite, and then make a final finish pass, and that does our edge. And we're leaving, our approximately 3/8 down here because we're going to be machining all of that off at the other side. All right, so now we're going to turn this to the top view now. And because Esprit remembers everything that we did, I'm just going to go ahead and just pick this next one. And I'm going to say machining, solid mill traditional, and contouring. And I'm just going to hit OK because everything will be the same. It knows where the tangent start point is here, which is up here, and then where it ends. It knows it's going to the right of the profile, so I don't need to fill all that out. And that's a beautiful benefit of Esprit. So we're just going to go around here and do the same thing for each one of these. say OK. And then finally this one here. And I'm going to say machining, solid mill, contouring, and OK. So now we have our 4 chamfers done. The next thing we're going to do is the pocket, because we still have the 1/2 inch end mill, so we should continue using the 1/2 inch end mill until we're finished using it, because we don't want to have to do a tool change. That just takes time. If you're doing 1,000 of these, the less tool changes you have, the better. All right, so we'll do this pocket next with our roughing, and we'll say machining, solid mill, and pocketing. Now, under the general portion of this, we're going to be doing concentric out, starting from the middle and working our way out. That's the best one. You can see what I have here. Our total depth is 1/4 inch. We're going to do incremental at 1.125. And you can see I have region, yes, no, yes. And then we're going to go to reading to the pocket portion of this. We want to read the taper from the feature. I just leave that yes. It doesn't change anything, although there is no taper there. There is no island, so I'm not going to click on this box and choose an island. Rough, I have my speeds and feeds here for rough. It's conventional. I want to do the rough cut in the conventional mode, so just the way my arrow is, I want to go around this way, okay, as it advances from the center out. And I'm going to leave 10 thousandths on the wall that I can use the 1/4 inch end mill to pick out. So we should go back to general just for a moment here and just make sure we pick the correct tools. You'll notice that here that I have a rough pass, a wall finish, and a floor finish. And I have rough, then floors, then walls. So I'm going to rough this with the 1/2 inch end mill. Then I'm going to do the floors and the walls with the 1/4 inch, and that's what I have here. The rough tool is going to be the 1/2 inch. The finish is going to be the 1/4 inch end mill for the floor and for the walls. So we want to make sure that that's taken care of under general. And we've already done this, so we're going to go down back to rough again and make sure we have our feeds and speeds filled in. Conventional move, our step over is just a little under 1/2 inch, or half of the end mill's diameter. Stock allowance on the walls 10, stock allowance on the floors 10 thousandths, helical contained. Very good way of approaching this, and because the spree will find its own spot where it wants to helically come in and start machining operations somewhere in the center here. Wall finish is next. Again, we put our speeds and feeds here for that. Everything looks good there. Want to make sure we do our climb milling now for doing the finishing operations for the floor and for the walls. And so we'll be going basically in a counterclockwise direction for that. And we will use that to make a nice smooth wall here and a nice smooth floor. We want to do it on the last Z level, and of course we always do it around islands and boundaries. That's a default there. The next operation is going to be stock allowance on the wall 0, stock allowance on the floors 0. Tool offset radius, yes. Cutter comp left. Offset register 6. And the reason why it's left is because we're going to be going counterclockwise, is what I mentioned. So we want to make sure we tell it to do that. We want to make sure our tool is correct. So we're going to go in here and look and see if tool 6 is our 1/4 inch finish end mill, and it indeed is. All right, so then we are going to go back to our operation, finish this out. We're going to radius in and radius out at 100 thousandths. And our last category is our floor finish. Again, they're asking for speeds and feeds for the floor finish in case we want to change something. We're fine at 1200, 15, and 10 here. Cutting strategy is going to be climb milling again for doing the floors. As you see, there's no stock allowance or anything left. Helical contained again, same as before. and our exit mode is up, and retract distance is 100 thousandths. So I think that pretty much covers it, except for links. And if we look at the links, again, it's 100 thousandths clearance, return plane clearance, and clearance. There's no objects in the way, there's no clamps in the way here, so we should be in good shape. So we're going to say OK there, and now we're going to take a quick look at this and see what this looks like. Let's start out with our face milling operation. We do our chamfers. And then our pocket. Concentric out. Here's our 1/4 inch end mill. Pick out the corners, finish the wall and the floor. And that's it. So that looks good. We're going to go to the top view again, and we're going to go ahead and do our slots next with our 1/4 inch. We have the 1/4 inch end mill in now because we just use it to pick out the corners. So we're going to go ahead and get started with that. Machining, solid mill traditional, and contouring. And we're going to make sure we choose the 1/4 inch end mill and put in our speeds and feeds. That looks good there. Our strategy again is going to be rough pass, one finish pass. We're going to be going conventional on this, on every one of these. These are slots for bolts, so it's not important that we have a fine finish there on the walls. Process width, spiral move no, 10 thousandths on the walls. The total depth 1 inch 20 again, 270 incremental distance, and we have tool right, and offset register 5. Since we're using again the 1/4 inch end mill, let's look in here, and the 1/4 inch end mill is going to be tool number 6. So I'm going to make sure we put offset 6 here. Very important. And then our finish mode, again, this is going to be 1000 and 20 and 15 again. It's going to be conventional. It's going to be after all the roughs are done, and it's going to have be done at the last Z level, so we can finish that whole wall with one final 10 thousandths cut. Troy-Codal move no, trimming collapse. Everything you see here is pretty generic. Our links, clearance 100 thousandths. Retract is 100 thousandths above the part, and then for relieving chips, and then entry mode is down and over, and exit is feed over, wrap it up. Again, we're going to be using tangent here. Tangent is we're going to want to start out here, and we want to come in and go around and come straight out with, of course, the allowance of offsetting. G41, G42. In this case, we're going to be using cutter comp right. So we're going to use tangent, and I want to see what that looks like. So if we turn this up to isometric and we just do that operation, you can see what it's going to be doing. Tangentially coming in and going out, and of course we're going to stay off the bottom here because we know that we need to have at least we need to finish up here at 3/8 in the final step later on. So that's good. We're going to again do all of those, and Esprit will remember everything that we have done. So all I need to do is just pick up the chains, machining, solid mill traditional, contouring, and all I have to do is just say okay, and it's going to do exactly what the last one did. Right? And then we do the next one. Hit OK. And then our final one up here. Okay. All right, so let's take a look at what this looks like. Face milling, chamfering, pocketing, using a 1/2 inch first, 1/4 inch next to pick out the corners, finish the walls, finish the floors. Slotting, we use the 1/4 inch end mill. All right, so that looks good. We can take a quick look at everything. Everything looks pretty good here, and make sure you didn't miss anything here before you move on. All right, we're going to go to the top view again, and now we're going to do our final operation, which is going to be the drilling and tapping. So I'm going to go ahead and I'm going to pick this, and I'm going to say machining, solid mill traditional, and drilling. So I'm going to go up here and put down under general C drilling.